Okay, the next topic is looking at solving literal equations. So what that means is we're solving for a variable, and there might be other variables in the equation. So on this first one, we need to solve for y. So that means we're treating x as if it were another constant. So we want to get y by itself. That highlighter is not very good. Let's pick a different color. All right, we'll stay with the same color. Right, so we want to get that y by itself. So again, we're looking at sides of the equal sign. So the y only appears on the left side. That means I have to get rid of everything else. So this 3x, it's being added to this side. So to undo it, we're going to subtract 3x from both sides. So on the left side, 3x minus 3x is 0. So I have negative 6y equals, I cannot subtract 24 and 3x, so I just keep track of it. I write it as an expression. They are not similar terms. I can't combine them, so that's it. Now I've got negative 6 times y. So to solve, I'm going to divide both sides by negative 6. On the left side of the equation, negative 6 divided by negative 6 is 1, and 1 times y is y. And on the right side, I can leave it as is, or I can distribute that division of negative 6. So I can do 24 divided by negative 6 is negative 4. And then negative 3 divided by negative 6 is positive 1/2. I would reduce that, and I still have the x. Okay. This is a move that we'll do quite often. This is taking a line, which this is the equation of a line, and it's written in standard form, and we're converting it into slope-intercept form. So that's something we'll do quite often. A lot of times we may even want to write the x term first. So we arrange, and now it's y equals mx plus b. I'm sure you've seen this before. Here's another interesting one. Here's where these are all variables. Now, the y sub 2, this 2 does not have any kind of, it's not an operation. It's not like squaring or anything like that. It's just some subscript that's differentiating between this y and this y. So y sub 2 and y sub 1. They want us to solve for m. So again, m is on the right side of the equal sign. It's not on the left side. So we just have to get rid of all the other stuff. Now, some people here want to distribute the m first. But now, that's going to give you 2 terms with m in it. And that makes it much harder to solve. Or sort of, you're kind of going in the wrong direction. Not only that it's harder. If you want to solve for m, you want to have m just once would be awesome. That's the kind of the goal. If you have m only appearing once, then you can solve for it. So it's already only appearing once, so we're not going to do distributive property here. We're going to look at this as m times this whole block of stuff, this chunk of stuff in the parentheses. So since it's m times that, this is a pretty simple one-step solution here. I'm going to divide by that block of stuff on both sides. So over here, when I divide x2 minus x1 by itself, I get 1, and 1 times m is m. So I'm left with m equals, and now it's solved. I'm going to just write this in a different order. I'll write the m on the left side. I can switch sides of the equation. This should look familiar to you. This is our formula for slope. And this one I like to show because I like to show for literal equations because it's a way to remember. Everyone sort of remembers the formula for slope, but they forget the equation of a line in point slope form. And that's all we really have here. This is the equation of a line in point slope form. And so if you can remember the connection between these two, a lot of people remember the slope formula. That will help you remember the equation of a line in point slope form. So in doing this literal equation, we've also done a little bit of review, a little bit of foreshadowing here. We've looked at the 3 different forms of equations of lines. We've got our slope-intercept form here. We've got our point slope form here. We've got standard form here. And we also have the formula for finding the slope of a line given 2 points.